Chapter 3, The Chemistry of Climate Change, Part 3. In this lecture, we'll be talking about the mass of atoms and introduce the concept of the mole. Let's first watch a few videos on Avogadro's number, or what is referred to as the mole. Now let's practice. Calculate the molar mass of carbon dioxide. So, in calculating the molar mass of carbon dioxide, first we need to look at the periodic table and find the molar masses of the individual elements. So carbon will be around 12.011 grams per 1 mole, although the unit will not be on the periodic table, you should add it. And then we've got 2 oxygen atoms, which are about 16 grams. It may say 15.99 something, but I'm just going to round to grams mole. Okay, and when we sum these up, we get about 44.01 grams per mole for the molecule of CO2. Thinker buddy, how many grams of CO2 are in 3 times 10 to the second moles of carbon dioxide? One thing I like to start with when I do these problems is write out a little roadmap. This helps me remember if I'm ever converting between grams to molecules, not in this case, but if I were to do that conversion, I would need to first calculate the number of moles. And how do we convert between grams and moles? We need our molar mass found on the periodic table, which I abbreviate MM. And how do we convert between moles and molecules? Well, in this case, we use Avogadro's number. But here we're only going from moles to grams, and it would be a one-step problem using the molar mass. So we start with 3.0 times 10 to the second moles of CO2. I like to write out as much information as I can in terms of units because it'll help me catch any mistakes and cancel later on. We know for every 1 mole of CO2, we have about 44 grams, which we calculated in the previous problem. Moles of CO2 cancel. We're left of grams of CO2 here, and we come up with 1.32 times 10 to the 4th grams of CO2. This ends the third part of Chapter 3, covering sections 3.6 and 3.7 in your text.